with that said, we're gonna do 5.3, which is gonna be solving exponential and logarithmic equations, and we are gonna use a circle method to do it. So whenever you hear the word solve, you're solving usually for what? Usually it's x. Sometimes it's for another variable. Usually you're solving for x. So what you'll see here is we are going to solve for x, and you're gonna have exponential equations, and some will be log equations that you'll have to solve and get x by itself. So here's the first one. Let's go to the first one. There's the first one. And then I'll do the change of base formula. All right, so here's the first type of equation we're gonna solve. It's already given you some steps. I'm gonna add some steps to it and explain. So the equation that you see on the board is 3,000 is equal to 150 times, what's that, 10 to the 4t power. Now, just looking at it for a second, don't look at this part, but just looking at the rest of the equation, is there an A, B, and a K? Yes. What's A? 150. What's B? 10. And what's K? 4. Okay, so again, this is still your stretch factor, right? In the homework, they'll call this the base. So you've got a stretch factor. Anytime you have something raised to an exponent, this is the base, and that's your exponent. So you've got your stretch factor and your base. Just make, because B stands for base. So remember, you got an A, B, and a K. So we're good? But all we're trying to do is solve and get what by itself? In this particular case, what letter did they use? T. So it's okay whether it could have been an X or a T, it don't matter. You solve for the letter that you see. Whichever variable that you see, we're going to solve for it. So, step 1. You're trying to get rid of everything on this side of the right side except for the T. So with step 1, divide both sides by whatever A is. What's A?
150.
So we're going to divide both sides by 150. Divide both sides by A. A happens to be 150. All righty. So I'm going to divide this by 150, and I'm going to divide this side by 150. You okay? All right. When I divide 3,000 by 150, what do I get?
200.
All right. Somebody said it already. What is it again? These two cancel out. Is that, try it again. Is it 20 or 200? 20, okay. All righty, this is 10 to the 14. All right, so we have just done step 1. Step 2 says do the circle method. Step 2, do circle method. All righty. So I'm just going to rewrite it so I can do it. All right, circle method says put a dot here under the 10, draw an arrow to the 20, and then an arrow to the 4t. The whole entire exponent is 4t, so you're drawing an arrow to the 4t. All righty, so we just did our circle. Step 3, write or rewrite in log form using the circle. Rewrite in log form using the circle that you just created. Alrighty, so log, box goes here. What goes in this box?
10.
Okay, so I'm going to put a 10 here. What goes in the second box?
20.
Last box?
40.
Thank you. Now, you ain't got to put those boxes on your paper though. You know, I'm just doing it so you know where to put those numbers. You okay? What we trying to get by itself again? Trying to get t by itself. Now, I have one question for you. Whenever this is a 10, will you ever have to put it in your calculator with the 10? No. The calculator automatically defaults to base 10. So you never ever have to write log base 10 of 20 in the calculator. You literally, I'm just gonna rewrite it in that way. You're literally gonna do log base 20 equals 4t. The only time you don't put that little bitty number is when it's a 10. Any other number, you gotta put it. Whether it be 2, 5, 15, 1 million, you gotta put that number. In the calculator, when it's a 10, you don't have to put anything, you just put log 20.
So if you do put the 10 in the calculator,
It shouldn't, the key that what I'm saying now is that you have a button on your calculator. Does it say this? You also may have a button on your calculator that says this, or it might put an X there. So if your calculator has just this button, you can do it just like it is. If it has this button, you're asking me if I put a 10 here, will it mark it wrong? No, it's gonna still mark it right. So we'll talk about that button that you might have in a second. So here's the question again. What do I put in the calculator right now? Log 20. What did you get? 1.30? Okay, so you're gonna get a whole bunch of numbers. So at this point, what should you divide that by? So whatever the number you just got divided by 4, tell me what the answer is. In the homework, it's gonna ask you either for 3 or 4 decimal places. So give me 4. 0.325. I need another place. 0.325.
2.
2.
So, Professor Harris, so in your calculator, you're gonna put log 20 equals 14, or just log 20?
You can't put 4t in the calculator.
Oh,
Your calculator will not let you put variables in there unless you got one of those special calculators that does the work for you.
okay.
So let me not say that. It does if you have a calculator that does the work for you. You can put variables in there. In this case, I want you to put log 20, divide by 4, and it should equal that. So you need to try that. You need to make sure if you put log 20, you hit enter and then hit divide by 4. Or you can type it all in at the same time. Log 20 divided by 4 in the calculator at one time. It's your choice. I would prefer you put log 20, hit equals or enter, then hit divide by 4. So let me say what I said. Put log 20 in the calculator, equals whatever that comes out to be, and then hit /4.
So we have to divide it by whatever that number is.
Whatever the number that sits in front of the T.
Okay.
So if it's a 4, divide by 4. If it's a 5 or 15 or whatever number it is, divide by both sides by that number. Okay, questions?
What stuff is that? We divide by
Step 4 is, now again, this step will change depending on what's here and what's here. So this just solve and get t by itself. That's what step 4 should say, solve, or just put get t by itself. Okay, that's what you should be doing at that step, get t by itself. So in order to get t by itself, you would have to divide by 4. Alrighty? Now, they did what we did over here. They just kind of left out a few steps that I added in. But that's exactly what they just did. We okay? Alrighty. You're solving what kind of equation was this? Exponential equation. Alrighty, so now we're going to do another one that's also an exponential equation, but I need to show you one other step before we do it. So I'm going to show you this slide, but I need you to know this formula before I show you that equation because it's going to require you to use this. So I should have moved those slides around. Alright, so here is the change of base formula. Alrighty, so if I say what's log base 3 of 9, you have two ways to do this problem. Now I know the answer, but the question is you got two ways to do this answer. If your calculator has this button, you can type it just like that. Does your calculator have this button? Meaning it lets you change the number that I put here. Can I change the base? Does your calculator have the button that lets you change the base? If you do, put it in just like you see it and tell me what the answer is. If your calculator does not have this button, you've got to write this problem this way. What's the answer? You got two? Okay. Who did it this way? When you didn't have to, you just could put it in just like that. Okay. Who did it this way? Okay. What did you get? Okay. So what was the point of this? This is called change the base, because if you don't have this button, you can't do it this way. You have to do it this way. So this one right here is called the change of base formula, because it allows you to change the base to get the answer. What's the base? What is the base over here when there's no base? 10. So notice, in order to write it this way, if your calculator doesn't have this button, did you have to change the base? What's the base now? 10 and 10. So did you change the base in order to get the answer? You did if you didn't have this button on your calculator. So they're calling this the change of base formula. You only need it if your calculator does not have that button. Okay? We're okay? Yes.
So you guys do it, because I don't have that button, so I have to do the division, so I literally type in log 9, log 3, log 9 divided by log 3, and I get T.
We're gonna do it different.
You supposed to put it
No, you don't have to put it down.
All right. Here's what could happen if you do this. If you don't put parentheses here, your calculator may think you meant something else. You got what I'm saying?
So sometimes you need, okay.
So-
it would just be safe to put parentheses around it in the beginning to.
Right. Some people's calculator automatically know you meant this. Some calculators you have to put this in parentheses, otherwise it thinks you meant something else. Okay? Question. Now, this is going to be needed for the next equation that we're going to solve. All right, so let me go back to that equation. So here's the equation we're going to solve. Am I going to use the same steps that we use over here?
Yes.
Yes. And there is one exception. All right, that's to the 2x power. All right, so I've got 4,096 equals 8 to the 2x power. Is that an exponential function?
Yes.
What's A?
8,000.
Okay, so let me ask you again. Look at this over here. What was A?
150.
What's B? What's K? Okay, ignoring this number, what's A?
8.
Okay, let me go back over here again. What's A?
150.
What's B? And what was K?
14.
B always gets raised to whatever K is. B, whatever number B represents, always gets raised to whatever the K is. So what you did, you said this was A, the 150 is A, the B is 10, and the 4 is K. So let me go back over here again. Ignoring that number right here. What's A?
8.
Okay, y'all looking at me strange, like, why she keep asking us this question? This is B, and it's only the number that gets raised to a power.
So there is no A.
So there's no A. When A is not there, it's just 1, and we never put the 1. We said that when we first learned about exponential functions. Remember, when we learned about exponential functions, we said there was always gonna be a B, and a K. Now, when there's no A, what's A? 1. So notice there's a 150, but you don't have one here, so in this particular case, A is 1. So again, what's A?
1.
B, K.
2.
Got it? Okay, so you're not always gonna have a A.
But we have to remember that is 1.
It is 1.
Because
Okay.
calculation purposes, we need to know that.
Well, for just understanding what, if you had to divide both sides by 150, you would need to know that. In this particular case, the question is, what's A again?
1.
1. So do we need to divide both sides by 1?
No.
No, so we skip step 1.
Okay.
If there is no A, skip step 1. If you don't see an A, or a value for the A, skip step 1, go right to step 2. So, what was step 2?
To do the circle method.
Okay, skip step 1, go to step 2. All right, so, my circle method, we said, let's do it. Dot under the 8, draw an arrow to 4096 and an arrow to X. What's step 3?
Rewrite it in log form.
Okay, rewrite in log form. LOG. Got a box. All right, what goes in the first box? What goes in the second box? Okay, I gotta move this one bigger so I can fit it in there. 4096 equals what?
X.
Okay. I gotta get what by itself? So we divide both sides by 2. However, I need to know what this is. Now, if you have the button, can you just put this in the calculator just like this?
Yes.
And then divide by 2? Yes, you can. But if you don't have the button, what should you be putting in your calculator?
Parentheses first, right?
Okay, yeah, parentheses, I'm gonna do that, but tell me what should go in the calculator. Log what?
Log 8, sorry.
Okay, log 8.
Log 8.
How you know what number goes on top and what number goes on the bottom?
Log 496.
Okay, the number that hangs low goes low.
Okay.
The number that hangs low goes low.
So log 8.
So
The number that hangs low goes low.
4,096 over 8.
Why is it 8 hanging low?
It is hanging low. The number that hangs low goes low. That means it goes down here.
Oh, okay, okay.
You got what I'm
I thought you were
saying?
saying 4,000.
So you're trying to, the question was, somebody said, how do I know whether to put the 4096 on top or the 8 on top? That was the question. Look back over here. The number that hangs low goes low. So look here, the 3 is on the bottom. Log of 3 goes on the bottom. Whatever number hangs low goes low. Or whatever number hangs toward the bottom goes on the bottom, however you want to say it. So now this got to go in your calculator. Those of you that don't have the button.
Yeah, 4.
What answer did you get?
4.
Ah, so I got a 4 equals 2x. What should I do now? Thank you. Now, when you put this in the calculator, sometimes it's not gonna come out to just be a whole number like 4. It might turn out to be something like 0.35798642. Whenever you're doing this, don't round till you get to the end. So if you had, when you put this in the calculator, if that had come up to be 1.7342695, put all of that in the calculator, divide by 2. Don't chop it off because the homework is gonna say round to 3 decimal places or 4 decimal places. So if you chop it off right there and then divide by 2, your answer's not gonna come out right. So I'm just saying, whenever you do this in your calculator, and if it comes out to be a big old long number, keep as many decimal places as you can, then divide by 2. Don't chop it off and divide by 2.
So just use the whole number then.
Yes. So when you get this number, keep it and just hit divide by 2.
Professor Henry,
Yes.
could you pass around some?
Oh, okay. Thank you. All righty. Questions? All righty. So, y'all didn't know you could do this in Desmos, right? You mean I did all this work and then I could just put this in Desmos? Yes. So, I need you to put the first one that we did in Desmos for me, please. And see if you get the same answer. So, on the first line, when you get in Desmos, put what the left side of the equation says. What's on the left side of that equation? Put y equals 3,000. On the right, on the next slot on Desmos, put y equals, what's this on the right side of the equation? What was on the right side of the original equation? So,
The parentheses around the 10 to the 14.
type it just like you see it. Okay, so let me put it in this, in here on my screen. There you go. All right, back to Desmos. Let's put this one in. Delete that because we don't need that. All right, so y equals 3,000. Whoops, you're not typing. All right, there I go. And y equals 150 times 10 raised to the what? 4t power. All righty. If you can't see anything on your screen, what's wrong? All right, now let me click back on home so you can see what happened when my screen just happened to be in the right mode. Now, I can see part of this on the screen, but I can't see the other part. You should see the red curve cross the blue somewhere. If you can't see it, your window's not big enough. Well, how big should my y-axis be? At least 3,000. So I'm going to go change it so that I can see where these two cross each other. So change my y, hey, just change it to 5,000. Now, where does the blue and the red cross? Is that the answer that we got? Notice they rounded it to 3 decimal places in Desmos. Is that the same answer we got? Yeah, if I round mine to 3 decimal places, I'm going to get the same answer. So we did all of the work manually, and you could check it using Desmos to see if you got the correct answer for X. For testing purposes, you need to know how to do it this way. Now, I'm going to say this again. For the final exam purposes, you get to use your laptop, your Desmos, and Zuora for the entire final exam. So, again, but for testing purposes, for my last test, you need to know this way too. All right, questions? We're good? So you know how to put this in Desmos? Put the right side in Desmos, put the left side in Desmos, and see where they cross. All right, so put the second one in there that we did. You put the second equation. We had 4,096 equals 8 to the 2x power. Put it in Desmos for me, please. Alrighty, let me put it in so I can see what you see. So this changes to 4,096. And this changes to 8 raised to the 2x power. All right, where they cross is the answer. Is that the answer that we got? Easy. So the good thing about this is you can check it this way.
I have a question.
Yes.
If you just, since it's always giving you the Y as the first equation that you put in,
Mm-hmm.
if you just, what happens if you just put in y equals 8 to the 2x power?
Then you just get this curve. You just don't know where, you don't know where 4,000 is. I mean, you can see it on the screen, but now you gotta say, okay, let me come over here, cause I wanna know when the value is gonna be 4,000. So now you gotta try to guess and put your cursor and make sure you get it exactly on there. So let's, exactly, so we know exactly, we don't have to drag our cursor around to see if we on it exactly.
You know exactly where the 2 is.
Yep.
In reference to the 4,000.
Correct, that's correct. All right, question? Alrighty, so in the next slide of the PowerPoint, it basically says you can use this information to do it graphically, which was what we just did. Okay? Alrighty, that is the end of 5.3. We're gonna take a look at 5.4, and then I want you to go to the homework, because there's a couple of homework questions I need to make sure we go over. So 5.4, most of it is just you putting the data in Zuru, and it's gonna create an equation for you. The difference is it wants you to create multiple equations. They want you to look at maybe a linear equation. They want you to look at an exponential equation. They want you to look at a power equation. You might have to pick a quadratic. You're just putting data in multiple places so that you can pick the right equation that matches the data. That's what most of this section does. So let's go there. The first one wants to give you some data, and it wants you to tell me, is there an exponential equation that matches the data exactly, approximately, or not at all? What did we used to do when we were asked that question? There was something you had to do if it asked you if there's data, this data matches the equation exactly, approximately, or not at all. We had to do first differences. So here is my data. All right, so what I've written on the board is X and Y table. The X values are 1, 2, 3, 4, 5. The Y values are 1, 8, 27, 64, and 125. How you do first differences? Okay, so if I subtract 1 and 8, how much is that?
7.
Okay, what about 27 minus 8?
19.
19. And what about 64 minus 8? What is that, 37? Is that 37?
Yes.
Okay, and 125 minus 64? All right, we're almost done. Now you can see right now, those numbers are not the same, are they?
No.
They're not close either. We got one more step that you have to do, which is called the percent change. In order to find the percent, don't you always have to divide? Yeah, so instead of finding just the first difference, they want you to divide and find the percent. And if the percentages are the same, then we can say there is an equation that matches the data. So what was the first step we did?
The first difference.
And we do the first difference by doing what? So we're gonna subtract and then divide. So step 1 was subtract. Step 2, divide. So here's our division. We're gonna divide by what? Divide by the first number that you subtracted. What was the first number that we subtracted by? 1. All right, so divide by 1. How much is that?
7.
All righty. Divide this by how much? Divide by the first number. The first 2 of these numbers. 8. Divide this one by,
27.
and this one. Somebody do the calculator and tell me what this is. So this one's 7. I'm good. What is this one? 19 divided by 8. I know 8 goes into 19 at least 2 times, so it's got to be 2 point something. Give me 2.4. I'm going to round it. 2.4. Okay, what about 37 divided by 27? 1 point what? So 1.4? Okay, and 61 divided by 64? 0.9? 0.9? Okay, we could call it 1, but I'm gonna leave it as, because I got 1 decimal place. Now, are those numbers the same?
No.
Are they close? Not really. So we're gonna say there's not an equation that models that data. There's not an exponential equation. You only do this for what? Exponential equations. The other ones that we used to do, we were doing linear equations where we had to do this. So you're doing this method for exponential equations, and it's called the percent change. So the percent of change here is not the same. They're different and they're not close. Alrighty? We're good? So in the homework, there's a question like this in the homework.
So step 2 is divide by the number you subtract.
So, and it should say, the homework question should say divide, or the instructions will say divide by the initial output. Or the initial Y value. These are all output values, right? Or I should say divide by the initial Y. Doesn't matter whichever way you want to call it. Divide by the initial Y value, meaning the first Y value that you subtracted. So we subtracted these, divide by the initial one. Here, divide by the initial one.
Okay, so you, for me, you divide the results by what you subtracted to get that result.
What you subtracted from, yes. Okay, question? Okay, alrighty, so now that you know how to do that, you know that's coming up in the homework. Here is the next one. The next one says they're gonna give you some homework and they want you to look at growth and growth and decay equations slightly different. So, let me go back up here and write this again. Do you remember this? That's the standard form of an exponential equation, y equals a times b raised to the kx power. They're saying in this slide, I need you to look at b a little bit different because I'm going to give you some information about b. So here's the information I'm going to tell you about b. B could be written as 1 plus r, or b could be written as 1 minus r. R happens to be a rate, like a percentage. R happens to be the rate, like a percentage. The percentage could be, or the rate could be 0.3 or 3%. So the A stays like it is. Instead of it having a K, the K is going to be 1 in this case. Got it? K is 1. So I'm going to write that here. K equals 1. So I'm going to leave this as just X. So all I'm trying to make sure of is that you can see that A is the same, X is the same, we're just making K equal to 1. So now the question is, can you see that those are still exponential functions? Is the X Mona?
Yes.
So it's still an exponential function. The question is, what's the value going to be in here and here? Well, it depends on what the rate is. It depends on what the rate is. So if I tell you that the rate is 3%, can you figure out what B is going to be?
1 plus 3.
If R equals 3%,
1 plus 0.03.
so Y is going to be equal to whatever A is. They are going to give you a value for A. So in this case right now, A, I don't know what A is yet. But what's 1 plus, how do I write 3%? Can I put it as just 3 in the percent symbol? No, what should I put?
0.03.
Alrighty, raised to the x power. Can I simplify this a little bit more? If I want to simplify it a little bit more, that's going to be A times what? 1.03?
Yeah.
Okay.
That's just an example.
So here's an example. I just told you R was 3%. A is 1,000. So you've got something to plug in here. If R is 3% and A is 1,000, now let's plug in some numbers so you can see. Alrighty, so this is, let me change it down here on this end. Let me leave this like it was. and changed it. So now, this should be an arrow. Right here is gonna be 1,000. 1.03.
Professor?
Yes.
Okay, I'm confused, how do we determine which one we use? Y equals A in parentheses, 1 plus R, or Y, why?
Very good question. In the homework, it's gonna say, this particular situation is increasing by 3%. So, do I use this one or this one?
Well, if it's increasing, it's addition.
Uh-huh. And in the case where it's subtraction, it's gonna say this particular situation is decreasing by 5%. So you're gonna use the minus.
Okay,
So that's how it'll-
It kinda just threw me off.
Yeah,
Which one
it
do
will
you use?
specifically say increasing or decreasing in the actual problem.
Okay.
So you determine based upon that which one you should use. So again, here, if it says it's increasing, again, I'll put this here, this one is increasing. So we use this one. And of course, just to do this other one, if we had 50, so again, A equals 50, and R equals 9%, and it is decreasing. So now I'm gonna,
When you give us A, we just throw it in the equation,
you just throw it in the equation. So,
where K would be.
correct. So here, I'm gonna put A is 50. This is gonna be 1 minus whatever R is. So now let's replace all those numbers. So A is 50. Y equals 50 times what?
One,
Okay,
one,
let me put
one minus 0.09.
0.09. Well, what should that end up being? 1 minus 0.09. How much is that again?
Is it
0.91. Okay. All right, raise the dance power. All righty. Now, which one of these is increasing and which one's decreasing? This one or this one?
The one at the top is increasing.
The one at the top is increasing, the one at the bottom is decreasing. How did you know that?
Because the number got the
When you
word.
told us that it was decreasing,
Okay, I told you it was decreasing, and then what else did we remember about A, B, and K? When B, this is B, right? This is A, this is B, and then K is 1. When B is between 0 and 1, it's decreasing. That was something that you learned when we first started talking about these type of exponential. We talked about A, B, and K. So you're right. We told you it was decreasing, so you knew it was going to be a downhill curve. All right, so let's go do some of these. The next slide just basically says, hey, when you get to the homework, they're going to ask you to find the quadratic equation, the power equation, and the exponential equation, and some may say linear. Where are you going to go get those equations from? Zuru. So you're going to paste data, and you're going to go see which one is the best fit for the data. So here's what's going to happen, just so you can see what I mean. You're going to be given some data. And it's going to say, put this data in Desmos. This is what it's going to say, put data in Desmos. Why should I put the data in Desmos? What's going to happen? What do you do? What do you?
out of equation, right?
You are going to come up with an equation, but why do I need to put the data in Desmos? It's going to show you the. If I say I got data, here's my data. I'm just making these numbers up, guys. I said I got some data, and I said I want you to go put this data in Desmos. Why do you even want to put it in there? So what? It's going to graph it. What's it going to graph?
A scatter plot?
It's going to graph a scatter plot or points, whichever way you want to say it. If you put these in Desmos, you're going to just see some points, right? Right?
But how do you put it in Desmos?
Type them one by one. 1, 2, 110, 2, 20. Well, in your case, you're not gonna type, right? What you gonna do? Aren't y'all gonna cut and paste? Yeah, y'all gonna copy and paste. Y'all are not gonna have to type this in My Math Lab. So you're gonna copy the data from My Math Lab and paste it in Desmos. So you can see your points. So if your points look like, if those are your points from the graph that we have, from the data that we have, and then in the homework, it's gonna say, now go create a power equation, create me a quadratic equation, and create me an exponential equation. Or it's gonna say create all of those equations, and where you gonna put them at? Where you gonna create them at? Zero. So you gotta go paste the data in. You in Zero. So we're gonna go to Zero and paste the data. Okay, so paste your data in Zero, and it's gonna give you what?
Yeah, but which one we use, power, which,
All of them.
Okay.
huh?
We're gonna do it. I'm gonna show you. So when you get the data, put the data in the power power page of Zero. It's gonna give you an equation. Hold on to that equation. Open up a second screen. Go to the quadratic window. Which one is quadratic in Zero? PR. Paste your data. It's gonna give you another equation when you hit calculate. Hold on to that screen. Open another window and go to the exponential tab at the top of the screen. It's gonna create a third one, and you take all three of those equations and put them in Desmos and see which one comes the closest to the dots.
Oh, okay, so that's, now I understand. That's why we're putting it in Desmos, to get the scatter point, to see whether it's exact.
Right. So for example, the power equation might look like that. Your quadratic equation might look like this. And then your exponential equation might look like that. Which one of those is the closest to the dots? That's what they're asking you. Which one is the best fit?
When you say the closest to the dots,
The scatter.
Your
plot
data.
that
You
you're
put
gonna-
data in here so you can see them. So you put some dots in here by pasting your points in Desmos. So now you got these points all over the place. Which one of these curves comes the closest to all those points? They call that the best fit. Thank you. So that's what you're gonna do. So let's go to the homework, please. So we are done with 5.4. Pull up the homework because you need to see this. 5.3. Go to 5.3 first.
So 5.3.
Mm-hmm. Alrighty. Okay, so just in case you guys didn't know, I said this already, all the homework and quizzes are already open. They should be open up until the 2nd or 3rd of May. Okay. So as you can see, I've already changed them, so everything is due on May 3rd. Okay, alrighty. So with that said, let me go to homework assignments. Scroll down where I can see. All right, 5.3. Let's look at, I'm just gonna kind of scroll through them and see which ones I know I need to take a second look at. All right, number 1, it wants you to solve the equation. Which method are you gonna use? Are you gonna have to divide by A, or is there A? Is there A? No A. Which one what method you gonna use? The second one.
The change of base.
When I say second, I'm talking about either this one or this one. I'm saying the change of base, you have to determine that later in the problem. You can determine if you need to do the change of base later in the problem. But I want to know, are you going to divide by A or not divide by A? There is no A, so you don't have A to divide by. So you're going to do that one in the method you see for the second one at the top of the board. Alrighty? I'm just skipping through here so I can see if there's anything that you need to know. Number 2 is done like the second one. However, instead of LOG, what are you going to use? LN. Anytime it's e to the something, you gotta do the same method, but we're using LN. So let's take a look. Do I have, okay, that one. E to the t equals 914. Do I have an a value to divide by? No, so I'm gonna do this. So I skip and go to step 2. What's step 2 say?
Circle method.
Okay, so I put a dot here, draw my arrow. All right, now what was step 3? Write it in log form? All right, so log form, I gotta do LN, not LOG. Whenever there's an E, you gotta use LN, not LOG. So this is called the natural log. All right, so here, what goes here? So there's an E, you're never gonna see that letter there. I'm putting it there so you know that that's why we use the E, but you're never ever gonna put this in the calculator with that E there. All right, what goes in the next box? 914. Okay. Last box.
T.
So what do you put in your calculator? Natural log of 914 equals T. Don't put the T in the calculator. I mean, just put the natural log of 914 goes in the calculator. That's it. Once you put that in the calculator, natural log, what's the natural log of 914? Somebody tell me.
6.817.
6 point, and how many decimal places do they want? 6.817. What's the number after the 7?
8.
So do I round this up to an 8? Yes. Alrighty, so that's that one. Look at this one. This one, middle of the board at the top. Do you have the button?
No.
If you do, just put it in there just like it is. If you don't, guess what you gotta write? Or guess what you have to type into your calculator?
Log
Log what?
13.
Log what?
Log
Log
19.
19.
Divided by?
Log 4.
Okay. You okay? All righty. This one is written in exponential form. All righty, so what's different about this one?
It has a negative.
X plus 2.
Okay, it's got a negative x plus 2. What's the exponent here in this particular equation? What's the exponent? Negative x plus 2 is the whole entire exponent. So, do I just skip straight to the circle method? Yes. So, I've got 5, negative x plus 2 equals 29. Do the circle method. Dot here, here, and there. This is going around that's the whole thing. So, do I use LOG or LN?
LOG.
LOG.
LOG, so I'm going to use log. What goes in the first box?
29.
Okay. Wait. Tell me again what goes in the first box?
The first box.
Oh, 5.
5, and then,
29.
and then,
Negative x plus 2.
alrighty. So now, if you have the button, you can put this in the calculator just like that. If you don't have the button, what do you have to type? Log 29 over log 5. What do you get when you do this? One of these, you're gonna have to do this to see what that answer is. Log 29 divided by log 5, or if you have the button, put the whole thing in there, what do you get? You should get a long number.
Yeah. 2.09.
2 point, give me as many numbers as you can.
2.09.
5, 3, okay, I'll stop there. Alrighty, I wanna get x by itself, what should I do to both sides?
I mean, subtract
Divide
2.
it.
Subtract 2 from both sides, okay? If I subtract 2, what do I end up with?
0.09.
1, 0, 9, 2, 2, 1, 8, 5, 3. Divide both sides by?
1.
by -1. Divide that by -1, divide this by -1. So, of course, my final answer, x is equal to what? Well, let me put it over here.
A negative.
Now, how many decimal places does it want?
4 decimal places.
4 places, so I want 0.0922. So we didn't change anything we're doing.
Okay, but,
Go ahead.
okay, that's okay. I know what I was gonna ask.
Okay?
I know why I missed the steps, so
Okay.
that was my.
What if they give you a log equation and they want the answer? How do we solve that one? Do the circle method. So here we go again. I'm going to put it over here on this board. Log base 5 of x is equal to 3. Circle method. Where do I put my first dot? At the 5. It's already in log form, so what am I going to turn it back into? What kind of form? Exponential. So I need a box here, and a box here. What goes in the first box? What goes in the second box? Last box? What's the answer?
5 raised to the 3rd power.
And how much is that? 5 times 5 times 5 is?
125.
Done. So if you're given a log equation, you still have to do the circle method to find the answer. So if you have a log equation, you have to do the circle method to come up with your final answer. Let me see what else is in here. I'll come back to that one.
So actually, after we take our finals, this is still running, so you said to the 3rd of May, correct?
Yeah, because your final is on the first. And the reason why I'm doing it like that is because I have all the classes. If I let one class end on May 3rd, I just need to let all of them end on May 3rd. So I just did them all at the same time.
Then you go with 2 of each, right? 2 homework.
2 homework, 2 quizzes, and 1 test. All right, for number 7, you want the word log to be on the same, all the words that have log in it to be on the same side of the equal sign. I'm going to erase this part. So here I've got log base 4 of x is equal to log base 4 of 9 plus 3. Alrighty, so I am going to subtract log base 4 of 9 from both sides. Because I want the logs to be on the same side. So I'm going to subtract log base 4 of 9 from this side. Go over here, subtract log base 4 from 9 from the next side. That cancels out. So I have log base 4 of x minus log base 4 of 9 equals 3.
So, let's,
I want all the words that say log to be on the same side. Now I can use
so
my,
you subtract it from one side and add it to the other side.
I subtracted it from both sides. There's my subtraction sign.
Okay, and one cancels out, and then you just bring the other one down.
Correct.
Okay.
Alrighty? Now that you have a subtraction sign, we learned some properties that say times turns to addition, subtraction turns to division, and numbers that were exponents get pulled to the front. You have to use those now. You can use them backwards and forwards. So since division turned into subtraction, subtraction turns back to
Division.
okay? So here, I'm gonna have log base 4, and this is gonna end up being x over 9.
Can you explain that? I'm sorry.
there's a property that we learned a few days ago that said if you have log of 6 divided by 3, you can rewrite it as log of 6 minus log of 3.
Okay, yeah.
So you can use this property going backwards and forwards.
Okay, I'm here.
So if it's subtraction, turn it back into division and so forth. So all I
And so
did,
you don't have to put both of the fours because they're the
You
same.
just, cause they're the same.
you're compacting, you're compressing them.
Gotcha.
So once you compress them, you can't write log twice again.
And
You're
then
going back this method, you can only write the word log once.
Right, okay, and then also you put the X on the top because it's the first.
Correct. Whatever's first has to go on top.
I'm here.
So let me just kind of, there's my X here, there's my 9, so I'll put the X here and the 9.
Okay, I'm here.
Okay, still equals what?
3.
It still equals 3. Alrighty, just like that one, is it in log form? The one we just did, is it in log form?
That one,
Is it in simplified log form now?
it looks like it.
Okay, so I'm gonna do the circle method.
Okay.
So circle says put a dot here, to here, there. So now when it's in log form, what can I turn it back into exponential form? So I need, what goes in the first box?
4.
Second box?
3.
Last box?
X over 9.
Okay. Well, what's 4 to the third power? 4 times 4 times 4 is
54.
close. Let me make sure that's right. Maybe I was wrong. Hold on, maybe I was wrong.
It's 54, right? Or 64?
64, okay. So now 64 equals x over 9. What do I do to get x by itself?
Divide both sides by 9?
Do what now?
Multiply.
Multiply both sides by 9. 9 over here, 9 over here. So x is equal to whatever 9 times 64 is. What is that? 5 what?
76.
576.
Done.
Was X. Are we gonna have anything like this on the test?
Possible.
Oh.
The reason why you need to see this because I don't know that one of these is not on the final exam, so you still need to see this. You okay?
We gonna have to run back on some homework. Cause I know there's some stuff on there that you, cause I had went back, to try to like, redo it, see if I can get a higher grade.
Mhm.
There's some stuff on there that I know you did not teach us in class.
Like what?
But,
Let's see.
Yeah, you're gonna have to find it. Now, here's the point that you have to remember. When you talk about trying to figure out how to use, did we talk about how to do the circle method? Did we talk about how subtraction turns to division and multiplication? Now, what they did in this problem, they just combined all that stuff together.
Okay.
So it's expecting us to use everything we learned. You might just want to do it once and you be like, I don't want to do it all together. I just want to do the easy steps. You just say, look, I just want to do the circle method and get the answer. They're saying, yeah, you're going to do the circle method and get the answer, but we're going to complicate it a little bit and add some other stuff in so you can do some additional things. So I'm saying it's not just going to be one step type problem. They're going to ask you to use all of what you learned. So when you look at certain problems and you're like, we ain't do that. No, you didn't do a problem like this. That wasn't on the PowerPoint that I just showed you. I gave you these examples from the PowerPoint. I gave you those examples from the PowerPoint. So because we didn't do one exactly like what you said in the homework, doesn't mean we didn't cover the material. We covered the material in pieces, whereas they took this problem and brought a whole bunch of pieces together in one problem. Are you going to be expected to be stretched? Absolutely. The homework is going to stretch you. A test is going to stretch you. So it's asking you to kind of pull it all together and see if it makes sense all together. Now, here's what you do have to remember so you don't get frustrated by it. How many of these problems can you put on one test? Well, here's the point. The point is you can't I only do 15, 16 questions. So I've got 5 sections to cover. I can't put 5 of these on you see what I'm saying? So, but the point I'm making here is I don't want you to get frustrated when you see things that you like, oh my God, I don't know if I'm gonna be able to do that one all together by itself. Do as much as you can, but do everything else that you already know how to do. So don't let one problem stump you and be like, oh my God, I don't know if I'm gonna do it. No, that's just one problem, just one type of problem. Exactly. So that's what I'm saying. Don't stress over the little pieces that you miss when you know you got enough stuff that you do know how to do.
But you make up the test, right?
That test I do, final exam, it's a departmental test. But everything that's on the final exam, we have covered, and it's not hard, we have covered it. And if for some reason there's something on there, for some reason I didn't cover, I will make sure that I take care of that. But in general, we have covered everything that's on that final exam.
And how many questions are on it?
It's double what you normally see. So I give you 16, it's 32 or 33. You get 2 hours, and you get your computer to use for the entire test.
It's gonna be like
We can do and
And but we could use Desmond's and it won't count against us.
You can use Desmos and Zuru for the entire test wherever you want. You have to know, I can't tell you, hey, use it for problem number 5 and 6 and 7. You can use it for the entire test if you want to.
Do we still have to write out all the steps for a question?
The reason why I will say yes is up to you. Well, let me take it. You don't have to. But because I hand grade my test, I'm looking for the work that you should put on there just in case you make a mistake.
yeah.
You see what I'm saying? Because if you don't put anything on the paper and you made a mistake, I don't know where the answer came from. So I would still say show your work so that you can still receive partial credit for the things that you do get.
It's a multiple choice.
It's still multiple choice.
Still the same style of test that you had been giving us. Same style.
Same information that we've covered. It's just there's 32 of them or 33 of them as opposed to 16.
Oh, so that doesn't necessarily mean that, the
And
tests, that like 1 through 4 that you gave us, you, did those tests yourself, right?
All of the first 4, including the one we're getting ready to do, I created those tests myself.
So that does not necessarily mean for the final that we will see something that we've seen before.
Oh, absolutely. You will see a lot of what you've seen before.
Okay. No, I mean the exact problem.
No, you're not going to see the exact problem. That will definitely not be the case. You will
Okay.
not see. Now, will you see problems that look like what we did? Yes. But will there be one exactly like what we did, exactly on file? No, because it was departmental, so a whole bunch of people made it up together. So, yeah, we wouldn't have an exact problem from my test on there. No, definitely not.
And so you want us to study all the tests from previous, we're not doing a study. We're not doing that.
Well, you'll have 4 study guides that you've already been given, but I'm saying to you is we will use your 4 tests as the study guide for the test. But if you want additional, I would say use the study guide, all the study guides that you have.
Because you will not be going over that.
But Professor Harris, you said that Tuesday, at this card, for the support card, we're gonna go over one.
Am I gonna give extra homework? The study guide? The study guide for chapter 4, for test 4 should be coming this weekend, Saturday, someday-ish. You should get the study guide for test 4. Got a quick question. Oh,
The homework for problem 12 you had mentioned on Tuesday. Is this the one? Because I have problem grabbing it.
okay, so when you graph that one, you end up having to put this as your base and this as your horizontal stretch factor.
And is it?
Nice. So it's not gonna let you open that one back up. Let me open mine up. What number was that one again?
5.112.
I did. So let me stop it before it keeps, because it's already still going.